Hey everyone! In this tutorial, we're going to finish our stylized tavern scene in Blender 3D. We'll set up the materials, dial in the lighting, add animated vegetation, and set up visual effects. Before we get started, I made a few quick adjustments to our painted texture in Photoshop. You can use any image editing software you like. I saved it with the suffix colorize. Let's open the shading workspace and switch from Material Preview to Eevee Rendered mode. You can close the file browser panel on the left. There are no lights in our scene yet, so let me create a light collection in the outliner. Press Shift+A and add a sunlight. This light type is only affected by its rotation, but for convenience, I'll place it above and in front of the model. Instead of the complex principled BSDF node, we'll build our own material setup. Its foundation will be the Diffuse BSDF node, which allows the material to interact with light. Press Shift+A and add a color ramp node. Essentially, this is a gradient, and we'll use it to stylize our material. But since the Diffuse BSDF output is a shader signal, we can't connect it directly to the color ramp, so we convert it using a shader to RGB node first. Try moving the sliders around and watch how the lighting changes in the viewport. The closer the stops are, the sharper the transition. Now select these nodes and press Ctrl+G to group them. You can exit the node group anytime by pressing Tab. Inside the node group, let's add a mix color node. Set its blending mode to multiply and plug in our texture. Next, set the factor to 1 and drag the empty socket from the group input node into the overlay color input. Let's rename this new input socket to base color. Press N and you'll see it appear as a new parameter on our node group. Now connect the Tavern texture to it. Multiply applies the texture to all the lit areas. To change the shadow color, duplicate the Mix Color node and set its mode to Lighten. The shadow disappeared because the default white color brightened it up completely. Let's lower the brightness to a dark gray. We'll create a new parameter for the shadow color and name it Shadow Color. Now we can adjust the shadow color directly on the node group or in the Material Properties panel, which is much easier than searching for the node every time. Duplicate the Mix Color node once again and place it before the others. We'll use this one to set the light color. You can duplicate the Group Input node as many times as you like to avoid dragging noodle wires across the entire shader tree. Connect the new parameter to the light color input and name it Light Color. Let's duplicate the sunlight twice and set up a classic 3-point lighting setup, roughly like this. Rename the main light source to Key with a _R suffix. I'll explain why in just a moment. After the shader to RGB node, insert a separate color node to split the lighting into red, green, and blue channels. Assign these distinct colors to your light sources and name them Fill and Backlight. All of this lets us control the lighting intensity and range for each light independently. Let's add a frame node and place the setup responsible for our key light inside it. For clarity, we'll name it in the sidebar menu on the left. Add the prefix key to the light color input parameter. Now it controls the key light color. Next, duplicate this whole node setup along with the frame. Create a new parameter called Fill Light Color for the fill light color and rename the frame accordingly. Repeat the same process for the backlight. Now connect the green channel to the fill light setup and the blue channel to the backlight setup. Nothing has changed yet because we haven't wired them to the final output. We'll combine them using a Mix Color node set to Add mode. Let's temporarily disable the key and backlight. In the Fill Light's color ramp, expand the range. Change the fill light color in the input settings to a light blue tone to mimic skylight. In the light source settings, increase the angle parameter, which controls softness, to around 15 or higher. Adjust the angle and fine-tune the range using the additional color stop. Now let's turn the key light back on. Position it so that the cast shadows emphasize the shape of the tavern. Darken the faces along the x-axis and bump the key light intensity up to 2. Using a backlight here is optional. For instance, you could use it to illuminate the underside of the floating island or simulate a lantern glow if you modeled one. Right now, the shadows look pretty flat because there's no ambient occlusion or soft ambient shading built in. Let's add it using nodes. Create a new frame and name it AO. Add an ambient occlusion node inside it. If you have the Node Wrangler add-on enabled, press Ctrl plus Shift and click on the node to preview it directly. Now we can see the ambient occlusion pass. To control the sharpness of the occlusion, connect two color ramp nodes and mix them together. To do this, press Ctrl plus Shift and right-click drag to combine them. The first color ramp will handle sharp contrast, so set its interpolation to constant. The second one will be soft, so linear interpolation works great. The factor on the mix node blends these two gradients. Let's stick with a softer ambient shadow. Now let me add this setup to our main texture. Duplicate the Add node, connect the incoming color data to color B, and plug the occlusion mask into the factor input. Choose a color, switch the mode to Mix, and connect it to the output. To control the overall AO intensity, duplicate the Mix node and place it at the end of the chain. Change color B to pure white. Now the factor slider acts as an opacity control for the ambient occlusion. I'll brighten up the main shadow a bit, because adding ambient occlusion made it a little too dark. Let's compare before and after. Objects in the shadows look much more three-dimensional now. Feel free to experiment with color, softness, and opacity settings, or even expose an AO opacity parameter in the group input to make lighting tweaks even faster. Now let's add a few unique materials. First up is metal. Select the tap/faucet and duplicate the main material. Add the suffix metal. Since the node group is still linked to the original material, click the number icon next to the material name to make it single user. Step inside the group and create a new frame called Specular. Add a Specular BSDF, or Specular node, inside it. This will drive our metallic highlight. Change the base color to black. We need to convert the shader to an image signal and split it into 3 color channels. Mix 2 color ramp nodes, one sharp and one soft. Preview the output by Ctrl plus Shift clicking the node. To expand the size of the specular highlight, make the specular value brighter. We're getting 2 reflections here. Looks like the fill light color isn't completely pure green. Let's fix that. By adjusting the sliders on the lower color ramp, we control the strength of the soft highlight, while the upper one controls the size of the main glint. Duplicate the mix node and blend the result using multiply with any color you like to tint the highlight. Finally, plug this result back into the main chain using an add node. Before doing that, don't forget to save. Blender can sometimes crash during complex node operations. Select all the metal objects in the scene, press Ctrl plus L, and link materials to apply this new material to all of them. You can fine-tune shadow tones and light sharpness specifically for the metal material. If you want to tweak the base texture color, just use a Hue Saturation Value node. I'll slightly drop the saturation and value. For the stones, let's also create a separate material and make them a bit brighter using the same node. For the roof tiles, duplicate the main material because I want to dial back the fill light intensity. The easiest way to do this is to preview the color ramp directly. I'll also make the shadow color a bit more saturated. For the flag, I'll set a softer light transition to bring out the fabric texture. The biggest advantage of this shading approach is its flexibility. You can easily tailor it to any artistic style. Now let's replace the plain gray background with a gradient. In the shader editor, switch from Object to World Shading. The background node handles both the background color and environmental lighting. To control the visual background independently, add an RGB color node and mix it using a mix shader. Use a light path node with the Is Camera Ray output as the blending factor. Instead of a solid color, let's use a color ramp. Press Ctrl plus T to quickly add texture coordinate and mapping nodes, again thanks to the Node Wrangler add-on. Set the coordinate type to camera so the gradient aligns with our view. We can rotate the gradient using the rotation settings on the mapping node. For the gradient type, I recommend setting it to ease for a smoother roll-off. Pick colors to your liking. I'll go with one cool tone and one warm tone, making sure they complement the model's lighting. On the fill side, we'll use a deep blue, and on the key side, a reddish brown. Now let's create a stylized outline effect on our models. Select any object, add a new material slot, and create an outline material. Replace principled BSDF with an emission node and set the color to black or a dark shade. Make sure to enable backface culling and turn off shadow casting in the material settings. Now add a Solidify modifier to give the outline some thickness. Check Flip Normals, and under Material Offset, specify the index of our outline material slot. You'll see the outline appear. Set the thickness to around -0.015. That should be plenty. What we've effectively done is create an inverted, slightly offset shell of our mesh that only renders the outline material on its back faces. Let's copy this outline setup to the second log. Here, you can clearly see the ambient occlusion broke slightly. To fix it, uncheck the Fill Rim option in the Solidify modifier settings. Now link the outline material and copy the Solidify modifier to the remaining objects. Keep in mind that linking materials replaces all existing materials on target objects with the source object's material list. The same applies when copying modifiers. And with that, our shading is complete. If you made it this far, awesome job. Our Tavern model is looking great. Now let me wrap things up by adding vegetation, animation, and visual effects. Create a new collection named Grass to store our grass assets. Add a plane to the scene. For convenience, I'll switch back to solid mode and enter local view numpad/. In edit mode, shape the plane into a blade of grass like this. Add a few edge loops using Ctrl+R. These will allow the blade to bend smoothly. Use proportional editing to sculpt and refine the shape of our first grass blade. Add a center loop cut and merge the top vertices at the center. Add a simple deform modifier set to bend mode along the x-axis so we can control the bending amount. Enable Shade Auto Smooth for clean shading. Back in edit mode, select the central edge and pull it back along the y-axis to create a subtle crease down the middle. Adjust the auto smooth angle so the center crease remains a sharp edge. The first grass blade is done. Duplicate it with Shift+D and move it to the side. Modify the mesh to make it thinner and more uniform. In object mode, scale the mesh relative to its origin point at the base and press Ctrl+A to apply scale. Tweak the bend angle and silhouette slightly. Duplicate it once more to create a third grass variation. Once you're happy with the shape, we can add some wear and tear. Press K to activate the knife tool, cut across a section, and dissolve or delete the side edge. Add a few more notches like this. Next, add a cylinder. We don't need many sides, 6 vertices is plenty. Scale down the radius. The grass turned out a bit too large because I wasn't keeping an eye on real-world scale, so I'll scale all the grass models down in object mode and apply the scale. Taper the cylinder towards the top and move it down. Add several loop cuts using the scroll wheel and delete the bottom face. Merge the top vertices by pressing S, Shift+Z, then typing 0. Now we have a stem. Add a new plane and scale it down in edit mode. Shape it into a small leaf or wheat-like stalk element. Set its origin to the base, return to object mode, and snap it to the tip of the stem. You can tweak its shape or add additional edge loops as needed. Duplicate the leaf element, adjusting its position, rotation, and scale for each copy. Place around 5 copies, making sure the cluster looks three-dimensional and full from all angles. Select all of them and join them with the stem, Ctrl+J. Copy the simple deform modifier from the grass blade over to the stalk and ensure the origin is placed at the base on 0 coordinates. Now everything deforms properly. Duplicate the simple deform modifier and change the bend axis to give it a secondary bending direction. Make another copy of the stalk asset and scale it down. In edit mode, widen the stem slightly to balance out the smaller scale. We'll color these assets using Vertex colors, color attributes. This works like texture painting, but paints colors directly onto the mesh vertices instead of an image file. Detail resolution depends on vertex count, as each vertex stores color data. To clearly preview the colors, switch viewport shading to flat. Mask off parts of the grass and paint light and dark yellow tones. Towards the base, add richer reddish tones. Repeat this process for the other grass types, adding subtle greenish-yellow accents for variety. Make sure all colors harmonize nicely with the overall palette. For the stalks, paint a localized dark to light gradient to accentuate their form. Once the base colors are done, let's build the material. Add a temporary light source in local view and switch to rendered mode. Create a new material named grass. The base setup will match our main material. Diffuse BSDF, shader to RGB, and separate color. We can copy the remaining nodes straight from the Tavern material. Step inside the group, copy the color ramp, light color, shadow color, and base texture nodes, Ctrl+C, then paste them here, Ctrl+V, and connect them. To drive the base color, we'll pull data from our Vertex colors. Add a color attribute node and plug it into the mix setup. All that's left is tuning the shadow color, light color, and gradient range on the color ramp. Let's link this material across all vegetation objects right away. Tweak the nodes a bit and the material is practically done. A hue/saturation/value node lets us shift texture tones easily. Let's also use a color ramp as a blending mask. Connect a mapping node set to object coordinates. Color appears in the bright areas, so invert the gradient stops to darken the bottom of the assets. Here's the result, before and after. We've effectively created a custom ambient occlusion gradient. With a second hue/saturation/value node, we can easily shift the grass tint, making it greener or boosting saturation whenever needed. Rename the collection to Grass Base to keep our master assets safe. Duplicate the collection. We'll use these copies to build out the scene. Arrange grass blades and stalks into small clusters. Use Alt+D to create linked duplicates so they share geometry data. You can scale them freely without applying scale. Now, let's animate them. Select any object and open the graph editor in the lower panel. Go to frame 0 on the timeline, press I, and insert a rotation keyframe. Select the X rotation curve, open the sidebar, in panel, go to Modifiers, and add a noise modifier. The strength parameter sets the movement distance, while scale controls the frequency and speed of the motion. Hit play a few times to preview the sway, adjusting modifier values until you get a subtle wind effect. Depth controls the noise complexity. I recommend keeping it at 1 or lower for smooth wind. Once your noise curve looks good, copy the modifier and paste it onto the remaining rotation axes. Offset the phase/time on each axis so the movement feels organic and natural. Fine-tune the noise curves a bit. Next, select all vegetation objects except the animated one, and press Ctrl+A to rotation to deltas. This bakes their static rotations into delta values, preserving their unique transforms even as linked duplicates. Add the animated object to your selection last, then press Ctrl+L to link animation data. Now all selected grass instances share the sway animation. Applying rotation to deltas earlier ensured that frame 0 wouldn't reset their unique rotations. Looks great. Right now, changing one animation curve affects every copy. To make the animation unique per object, go to Object, Arrow, Relations Arrow, make Single User, Arrow, Object, and Animation. I like to add this to quick favorites. Once the animation is set up, add an empty object and parent the grass cluster to it, Ctrl+P. Now you can move the entire cluster easily using the empty. Position it somewhere nice in your scene. To duplicate a cluster, right-click the empty in the outliner, click Select Hierarchy, and press Alt+D to create linked duplicates. Scatter these clusters around your island. Make another copy and remove the stalks. If you want to change a cluster's orientation, unlink its animation data first, jump to frame 0, and rotate it. Otherwise, playing the timeline will snap it back to its original keyframe. Now you can place grass clusters everywhere, using Alt+D to duplicate, adjust, and rotate. Just remember to make animation data single user before tweaking orientation. I finished populating the scene off camera. For small hero dioramas like this, hand-placing clusters gives you maximum artistic control. For larger environments, though, a particle system or geometry node setup is definitely the way to go. Let's transfer this wind sway effect to the hanging fabric pieces. Select the fabric parts and apply rotation to deltas. Parent the hanging cloth strips to the rope knot objects so they rotate around the knot's origin. Select a grass blade, shift-select the knots, and link animation data, Ctrl+L. You can also link animation directly to the cloth meshes so they sway relative to their origins. Tweak the noise curve slightly so the fabric ripples naturally. Next, let's create a dusty wind effect blowing across the island surface. Create a collection named VFX. Add a path curve to the scene, enter Local View, and switch to Solid Shading. In Edit mode, shape it into a gentle S-curve and pull it out long. In the Curve properties under Geometry, increase the extrude value to give it width. Rotate the tilt of the handles by 90 degrees if needed. Taper the endpoints using Alt+S to shrink their radius. Flare out the middle section slightly. Open the shader editor, create a new material, and call it Sand Effect. Delete the principled BSDF node and add a color ramp along with texture coordinate and mapping nodes. Connect the color ramp output directly to the surface output and switch to Material Preview. Tighten the gradient stops, placing black on both sides of a narrow white band. Set mapping rotation Y to 31 degrees and Z to -31 degrees. Shift the gradient to the middle of the curve. Notice that with UV coordinates selected, the gradient stays anchored no matter how we deform the curve geometry. Widen the white band and sharpen its edges. You'll get a clean streak effect like this. Duplicate the gradient setup and mix it with the first one using a mix color node set to multiply with a factor of 1. Switch the second coordinate type to generated. Center the gradient, resetting location and rotation on its mapping node. Now, adjusting location X slides the gradient across, revealing or hiding our dust streak. Let's soft fade the outer edges so they don't clip abruptly. Duplicate the mix node and the gradient coordinate group again. Switch coordinates back to UV, preview the output, and reset mapping location. Set rotation Z to 45 degrees and adjust scale until the gradient centers along the curve. Move the black stops outward and set interpolation to linear for a soft falloff. Set scale X/Y to roughly 2.1. Combine this soft mask with our main streak using multiply. Now, add emission and transparent BSDF nodes. Emission drives color, while transparent controls invisibility. Mix them with a mix shader node using our procedural black and white mask as the factor input. Black areas become transparent, white areas stay opaque. In Material Properties under Settings, set Blend Mode to Alpha Blend. Pick a warm, bright yellow for the emission color and boost its strength. To make the dust wisps respond to scene lighting, add a Diffuse BSDF node. Pass it through Shader to RGB and split it with Separate Color. Use a color ramp to tighten the lighting pass and multiply this result into our procedural transparency mask. Let's jump into Rendered Preview so you can see how lighting drives the mask opacity. Pull the color ramp handles closer together for a sharp shadow transition. You can see how shadowed areas reduce the mask intensity, making the dust fade out and shade. Now, shift the Y location on the Reveal Gradient Mapping node so the wisp is hidden off-screen. Hover over the location property and press I to insert a keyframe. Move down to frame 60 or 80, slide the value across, and insert another keyframe. You can speed up or slow down this sweep, adjust the curve width, or rotate the angle. Play with it until it looks like a gust of wind sweeping up sand. To loop this animation seamlessly, hover over the graph editor, press Shift+E, and select Make Cyclic F Modifier. Now the motion loops continuously across the entire timeline. Shape and thicken parts of the curve as desired. Our first wind wisp is done. Duplicate it with Shift+D and edit the curve handles for a second stream. Right now, both wisps animate at the exact same moment, which looks unnatural. To fix this, make the sand effect material single user, select the keyframes in the graph editor, and offset them along the timeline. Now they sweep across out of sync. Duplicate the curve again to create a third wind trail, previewing the shader mask to dial in the silhouette easily. Now, let's build a clean wind trail effect. Duplicate one of the sand curves. In Curve Properties, set Extrude to 0 and increase bevel depth instead. Taper both ends to create a smooth, tube-like wisp. Duplicate the material, rename it Wind Effect, and inspect the mask. We won't need the first gradient node setup, so delete it along with its mix node. Connect the second gradient directly to drive the animation. Preview the material and tint the emission node to a soft sky blue tone. We don't need lighting interaction for this soft wind trail, so delete the shadow sensing node group. Instead, use Color B on the mix node to handle opacity. Darker values make the trail softer. Reduce the bevel thickness and position the curve around the building. This subtle effect adds depth and airiness to the scene, bringing the environment to life. Make a couple of duplicates. Place one around the back corner of the building, making its material single-user and offsetting the timeline keyframes. And place another sweeping over the roof. Editing curve handles in solid shading works best here. And here's our completed scene setup. I hope you love how it's turning out. Now, let's render and composite our final animation. Add a camera to the scene and position it close to our concept reference view. Press Ctrl plus numpad 0 to align the camera to your view. In Camera Properties under Viewport Display, crank up Passepartout opacity to 1 so you can see your composition clearly without distractions. I'll open a second viewport area to make positioning the camera easier. Set Camera Rotation X to 65 degrees. In Camera Settings, bump up the focal length, which controls zoom and perspective compression, to 90 millimeters. Back the camera up until the Tavern fits comfortably in the frame. Press F12 to take a quick test render. I'll slightly darken the background gradient using a hue/saturation/value node in World Shader mode. Render again, then jump over to the Compositing workspace and check Use Nodes. Now we'll add post-processing effects to sharpen our render. Add a viewer node so we can preview tweaks in real time. Adjust image scaling using a transform node if needed. Add a glare node to create soft, dreamy bloom. Set its mode to fog glow. Lowering the threshold brings more highlights into the glow effect, while size controls how far the glow spreads. Connect the glare output to the composite node so it applies to the final render output. Now, every rendered frame will include this compositing pass. Back in 3D Viewport, add an empty at the island's center and parent the camera to it, Ctrl plus P. Rotating the empty creates a smooth, turntable camera orbit around our scene. Keyframe the empty's location and rotation on frame 0. Set timeline duration. At 24 frames per second for a 12-second spin, type 24 × 12 into end frame to get 288 frames total. Go to frame 289 and set a keyframe on Z rotation for -360 degrees. Now, the camera spins smoothly clockwise. Add position keyframes for the empty as well. Since orbiting around a fixed center can sometimes cut off corners of the model, adjust the empty's position at a few points during the spin, and keyframe it to keep the Tavern perfectly framed. Once you're happy with the viewport preview, go to Output Properties. Set file format to FFmpeg video, open encoding, choose MPEG4 container, and set video codec to H.264. Select your destination path and file name. Press Ctrl plus F12 to render the full animation sequence. The top left corner of the render window shows current frame progress. Now, just sit back and let Blender do its magic. I also rendered out a crisp, high-res still render of the scene. That wraps up the third and final lesson of our Stylized Tavern series. I hope you enjoyed it, picked up some useful shading and animation techniques, or followed along step by step. Thank you so much for watching. Stay creative, and I'll see you in the next tutorial.